Well, hello, everyone. It's really, again, an honor to be here, and it's really an honor to follow up with Rick and the other speakers that you're having here. What I want to do is attempt to communicate in some sensible fashion what I have learned over the past, well, if we include smoking cannabis, 50 years. I've used cannabis for 50 years, but it's really been in the past few years that I've been able to assemble what I feel to be a fairly comprehensive and unique understanding, not simply of cannabis, because cannabis is only a significant part, but a part of life of all of us, since we all have an endocannabinoid system. Endocannabinoids means cannabis from within. So what I am going to do, and I have to ask your indulgence, what I want to do is take you through a series of logical developments that it's going to sound a lot initially like I'm not talking about cannabis at all. But if you don't understand what I am going to be talking to you, from everything I know, you're not going to be able to understand the magic of cannabis, hence the Magical Mystery Tour. Plus, it really is a mystery tour, because what we find with cannabis is so unexpected and so all-encompassing that at this point, I don't think anybody in the world with a brain, if they knew enough of the science, would do anything but enthusiastically support the use of cannabis as a life-extending essential nutrient. So what we're going to do is we're going to start off and look at what you're seeing. Oops, how come you're not seeing it? Huh. That page should be updated. I'm able to watch what's streaming. I don't know if you're seeing it, but I'm looking on my phone and I'm not seeing what I'm seeing on my computer, which is what you're supposed to be seeing. So if I could get some feedback regarding that, it would be useful. It's live. You see presentation topics now as the topic? Okay. All right, so as long as you're seeing that, we're all set. I didn't know what you're seeing, because what I'm looking at on the net is really quite delayed. Then I won't even bother. I thought it would be useful to watch that, but apparently not. So anyway, what I want to do is give you a very holistic understanding of what the basis of homeostasis is. And what homeostasis means is balance, really. But we're talking about biological balance. We're not talking about, two static entities that are balanced like on a seesaw. We're talking about something very different, because what we're talking about is the balance of flowing and changing entities. And what they ultimately are balancing, from my perspective, is the production of free radicals. And we'll see how that impinges on our lives as being the basis of aging and cancer. And what I want to do is give you the physics that'll lead us up to a very sound, comprehensive understanding of how this plant can impact on us, our health, our aging, in so many different ways. And I want to do that by presenting you with a real conceptual overview that, when you get it, it's actually very simple, and you can apply it everywhere to all fields of biology, because it's what underlies everything. This is the foundation of life. So that's what we'll be talking about, and we'll see how that underlying physics creates life, and then ultimately how the cannabinoid system is such an important regulator of life. And we'll see that it extends not simply at the level of infections or diseases, but rather as well to the level of our society and the very reason why we have things like racism. And in fact, what I will talk about is how the war on cannabis is a form of racism. And I don't simply mean because of all the people of color that get arrested in the United States, because it's the who is using these drugs. And if it was random, then you could say that there's no biases when you arrest people, even if you arrested them in an honorable or an honest way, as opposed to a racist way in the conventional sense. But the point that I'm trying to make is this, is that not all people are the same. And the people who use cannabis are intrinsically different from the people who don't. And that's why they chose to use it. They have a greater degree of open-mindedness and a greater degree of adventure. And that's all precipitated by the fact that they have a robust cannabinoid system which will help protect them from stress. So we'll elaborate on that later. I just wanted to kind of set things up so that you understand where we're going, and you'll tolerate me as I take us down this magical mystery tour journey. So, and this is what we've basically just talked about. In order to appreciate the impact of cannabis medicines, we've got to really understand the physical basis of what's going on. And we'll find out that the cannabinoid system is a unique manifestation of evolution. And because of life, what we have to look into is this branch of physics known as far from equilibrium thermodynamics. So in order to appreciate far from equilibrium, I want to first say what equilibrium is. So the easiest way to describe that, and we can elaborate a little bit more, but I want to try to convey the concept as simple as possible. An equilibrium condition is essentially a battery that's discharged. You can't do anything anymore. The chemistry that could have driven your light bulb or your motor or your car has already done its job. It's like having ashes, essentially, as opposed to wood to burn for heat. What we're left with are essentially the ashes when you're dealing with equilibrium. So far from equilibrium is where you have potential. And it's how that potential turns into life and how life works that we'll be looking at once again. So flowing energy, this is a critical concept here. Flowing energy organizes matter and results in emergent oscillatory behavior, the balance of opposing forces. Actually, I wanted to record this, so I forgot to do it. So hang on with me for 1 second, and I will do that. Okay. All right, so let's get to the next slide here. Somehow I can't seem to do that now. Oh, no. There we go. All right, sorry about that. So, what is life? Well, because last time you guys had recording problems, so I wanted to make sure we have a backup. So what is life? We're going to be looking at how the new physics and biology meet and how, from the perspective of far from equilibrium thermodynamics, life must occur. And that's what's so critical, because if you don't look at it from that perspective, you have to look at life as a miracle. And there's no connection between the miracle and the science that we know and live by. Whereas with the far from equilibrium thermodynamics, it tells you life must exist because flowing energy will organize matter. Flowing energy and molecular transformations that it creates is what powers life. And ultimately, that energy comes from the sun. So this work was pioneered by the Nobel laureate, Dr. Ilya Prigogine. And this quote that he liked gives us insight into the direction that we're going in. The more deeply we study the nature of time, the better we understand that duration means invention, creation of forms, and continuous elaboration of the absolutely new. So what he's talking about here is the flow of time. And what we wind up seeing is that the flow of time has this deviation capability built into it. As long as you're far from equilibrium, there is time, and in this absence, there essentially is no time. So what we're going to be looking at is a term known as entropy, which means disorder. And this is what provided the conundrum in the past. You know, how can life be so ordered when the second law of thermodynamics says that entropy, disorder, must always increase? So what he's come up with is the physics that's the opposite. And that's what we're going to be considering. Along those lines, this is a quote from one of his later books, The End of Certainty, which already tells you something interesting, the end of certainty. We are actually the children of the arrow of time, of evolution, not its progenitors. This is a very important statement to understand because conventional classical physics, specifically quantum theory, tells you that something only becomes real when it's measured. Well, that would say that the world we live in becomes real because humans are there perceiving it. And he says, no, that's ridiculous. And he comes up with a different way of looking at the world. He proves it mathematically so that it's basically this unfolding process that has created us as time proceeds. So here I want to give a quick example of what I'm talking about. What you're looking at here is a Petri dish, and it holds about 10 mLs of a liquid solution. And when you heat it from below, the only thing we're taught in the bulk of our classes, both with respect to physics and chemistry and biology, is that when you heat a collection of molecules, like we have in here, that they're going to vibrate more, they're going to rotate more, and they're going to spin around. What it says is impossible is what you're looking at. For these liquid molecules to form organized structures. So if you were to turn this on its side, you would see that the molecules are coming up in that periphery, giving off heat to the environment above, and then the cooled molecules are going down that center. So what you really have are hexagons, hexagonal convection cells that are better able to dissipate the heat. Essentially what's going on here is that above it, the environment, is becoming more disordered, whereas the system, the collection of molecules, is becoming ordered. Now, the probability, if you just poured out this liquid into this tube of forming these organized structures, is zero. But in fact, it happens, anytime you want to do it. So that tells you that you have to change your way of thinking and make it consistent with the reality that you can look at and see right in front of you. So now this is another example of a similar type of phenomenon. The last one we looked at, it was the flow of heat that created organization. In this situation, we're looking at something called the Belousov-Zhabotinsky reaction. And it was originally discovered in the 50s by Zhabotinsky. And when he went to publish it, he was told that they couldn't publish it because it will, it goes against the second law of thermodynamics. It says entropy must increase. Here you have a collection of molecules showing entropy decreasing. However, the specific of this reaction, so here we're driving organization by chemistry, a flow of chemistry, as opposed to in the last one where it was a flow of heat. And the chemistry that you're looking at here is actually very relevant to life because these are what's known as redox reactions. And what a redox reaction is, it's like electricity. The electricity goes from where you have a lot of electrons to a place where you don't have a lot, and you use the energy of those flowing electrons. Well, that's how we work. We use biological electricity as electrons flow from the food that we eat to the waste that we produce. Again, something that would be impossible by conventional thinking. So here I'm showing you a little movie of the process. So you can see how, as the reaction occurs, we're seeing organization. There's a chemical in this media that tells you whether the molecules are oxidized or reduced. Again, the idea of redox. So this is something that is completely improbable and impossible in reality from a standard point of view because you're looking at trillions and trillions and trillions of molecules that are cooperating with one another to form these structures so that the system gets smarter, quicker, at the expense of the universe, which is getting stupider quicker. Entropy decreases in the system, entropy increases in the surroundings. And on the next one here, I'm showing it to you in a test tube where I'm doing it, and it's shaken up, so we know that the molecules are fully randomized, and that indicator has a blue color. And we're going to see organization occurring once again. Watch the bottom of the tube, and you'll see a blue color move up the tube as the reaction occurs and reaches the point where the phenomena is happening. See, there's the color, moves up the test tube, disappears, and it'll come back and it'll do it again. Okay? Now, it's going to keep doing that for as long as the chemistry is flowing. In other words, it has not gone to equilibrium as long as this chemical potential in the reaction can occur. Now, the reason that was so important is now we're going to transit a little from the underlying physics to the biology. Because what you saw in that last picture was two types of organization. You saw organization in space by the patterns that you looked at. And on the other hand, you saw organization in time by the oscillation. The reaction comes and goes in that test tube that I showed you. So they're called also periodic reactions. And what you're looking at here are oscillations of chemicals. And these chemicals, without going into them, I mean, if you're knowledgeable, they'll already mean something to you. And if you're not, they're not going to mean anything, even if I really tell you specifically. But what you're looking at are molecules involved in energy production and how we live. And what you see is that there are two collections here that are exactly opposite one another in terms of phase. And we hear the same thing, but this group of molecules is not in phase with the upper ones, okay? So we're seeing that there are multiple phases to these oscillating reactions that are occurring, in this case, with a concentrated yeast extract. So here they've basically broken up the cells in a way that retains the quality of what was going on, aspects of the quality of what was going on in the cell, and you see these oscillations. Well, think of your lives. Your heart rate is oscillating. The EKGs are oscillations. Your brain waves are oscillations. Your sleep, wake, sleep. Major oscillation that gears so much of the rest of what's occurring within us, which is why it's so important to get good sleep, which, of course, obviously cannabis has a very significant role in that. And why? Because that's how your body makes you sleep. It produces endocannabinoid compounds that are involved in sleep regulation. So we would see that those pathways would be oscillating to give us our daily daylight, nighttime oscillations. And the consequences of not adhering to that are profound. You know, people who work night shifts have a higher rate of cancer. I've seen people who were suicidal and constantly depressed that once they got their sleep cycles correct, they became completely normal. And of course, they use cannabis to do that. So let's continue here. Dynamic balance of opposites. That's ultimately what is created whenever you're creating these flow-dependent structures, which go by a variety of names. They're called dissipative structures because they dissipate disorganization, entropy to their environment. They're also called flow-dependent structures because once the chemistry is done, the flow stops and the organization disappears. They're also spatial temporal structures because they're structures in time and space, okay? So it turns out that whenever you're having metabolism, which is the chemical pathways that generate energy, those would be catabolic breakdown pathways, as well as anabolic, like anabolic steroids. Those are the ones that create new body mass. And of course, there has to be a balance. And a very critical thought here, very, very important to understand, again, is if we're dealing with flow, you know, that's what's creating all of this, the flow of those electrons. Well, when those electrons flow, they flow in particular through organelles known as mitochondria. An organelle is a specialized structure in a cell. And those mitochondria, depending on how that energy flows, can either kill the cell or make the cell healthy, because that's what's providing the energy. So it's a very central focal point for whether a cell lives or dies, actually. And we'll be going into that. In any event, it's through the electron transport system when ATP, the main energy source of all life, is produced via what's a series of reactions known as the electron transport system. And it's from that electron transport system that you will always produce free radicals. It's an inevitable consequence of how things work. But you can produce more or less free radicals, and you can do different things with the ones that you're making in an effort to protect whatever the living system is. But the bottom line is that whenever a cell, an organ, an organism, a population, when any one of those layers is subject to change, that change is essentially stressful. And that stress manifests itself as free radicals. So because electron flow is central to life, redox reactions, and associated free radical production, any change that a cell experiences is stress and results in increased free radical production. This is what I'm proposing, and there's a ton of science that supports all of the things that I'm telling you. And in fact, I'm in the process of writing a paper. Well, it started out as a paper, but I'm up to 27 pages and probably only halfway through, so I think I'm going to turn it into a monograph. And what it's going to be is really a scientific presentation of the concepts that I'm providing you with. So perturbations in biochemical flow tend to produce free radicals. And those free radicals, by definition, are extremely reactive. By definition, they have an unpaired electron, and any compound, any molecule or atom that has an unpaired electron is extremely reactive because electrons always like to exist in pairs. So those free radicals can interact with our DNA, our RNA, our lipids, or our proteins. And in doing so, because they're so reactive, they change these things. So the change that occurs in these essential biological molecules served as the basis in 1957, I think it was, of the free radical theory of aging, that you're damaging these components and that they're wearing out, so to speak. Well, that's really looking at it from an equilibrium perspective, because what we're really concerned with is the rate of degradation versus the rate of synthesis of whatever biological component we're looking at. And it turns out that when you're young, you naturally have a balance in favor of synthesis. And as you get older, and in fact what aging is the accumulation of change that brings the collection of molecules of the person back to equilibrium, and that constitutes the phase change known as death, a far from equilibrium phase change. It's the same as ice melting and going to water. There's less structure, but in the case of ice and water, it's not dependent on flow. The system is in equilibrium with its environment, either warm enough or cold enough to produce liquid or ice. Here we're looking at a slightly different circumstance. We're looking at how, in addition to quenching molecules, getting rid of free radicals, things like vitamin E and vitamin C and variety of antioxidants, which chemically directly interact with the free radicals. Here we're looking at how the production of free radicals gets modified by changing the energy generating paths that are responsible for life. And what we're going to see is the cannabinoids play a fundamental role in this fundamental process. We will get to cannabinoids shortly, but it's really important for you to have this understanding of how life works, because how can you begin to understand how cannabis works when it's at the center of life of vertebrates? The cannabinoid system, the endocannabinoid system, as opposed to the plants, which are phytocannabinoids. But because the phytocannabinoids interact with the endocannabinoid system, that's how we get the benefits of consuming the plant for a variety of illnesses. And because the processes that we're talking about are common to all life. So an imbalance that can give you an autoimmune disease or heart disease or cancer, we're always talking about the same fundamental underlying process of how cells work, how they normally work together, how they talk to one another, and how when you're healthy, they're working in synchrony with one another, and they're keeping the system highly organized and far from equilibrium. But as you age, the communication of the system ages because of the buildup of not the damages per se, but the consequences of those damages in terms of how they change the biochemistry, the flow of the cell. An old person versus a baby, the biochemistry is very, very different. So let's continue. Molecular changes become communication that alters biochemical pathways in order to promote smooth flow, a more efficient exchange of nourishment and waste with the environment. All right. So the way to best understand communication between cells is frequently it's dealing with receptors that are on the surface of cells. And one cell will put out a compound that the receptor will bind to, and it'll in turn change the biochemistry within that cell. So a growth factor, for example, tells the cell to divide. A cannabinoid receptor does a whole bunch of things to the cell in terms of changing many, many different parameters, but ultimately we can understand it all by understanding how it affects free radical production. So any disharmony on any scale produces free radical inducing stress. Free radicals, on the one hand, promote degradation because they're changing your biochemicals. On the other hand, those changed biochemicals act as signals so that the system evaluates by virtue of those signals what's going on. And again, the signals are the words, the equivalent of words, and the receptors are the equivalent of ears. And just the way your biochemistry changes when you hear things, because you're creating nerve impulses and all sorts of things, consciousness, it's the same kind of a story within a cell. It's hearing the environment and it's responding to it in an effort to optimize survival. Now, we've got to keep in mind that you can deal with cell survival, which in a healthy individual is geared and integrated with the whole organism survival. Whereas in an unhealthy situation, specific cells are no longer playing nicely with their neighbors, and their neighbors could be anywhere in your body. Because of how cells communicate. In any event, so signal transduction of environmental information is very, very critical for a cell to adjust itself. So that's a very positive role. And another positive role is that you can actually utilize free radicals as weapons. So some of our immune systems, and I'll show you examples of this in a little while, actually make free radicals, spit them out on their so-called front end, and use them to basically irradiate pathogens or infected cells of yourself. The reason I said irradiate is because free radicals are how radiation damages things as well. It splits water and makes free radicals, which then react with everything. So back to the idea of dissipative structures. What is flowing? Well, what's flowing is the energy and the mass, right? We're eating that food, we're putting out our waste, we're breathing oxygen so we can burn the food to create the waste, all right? Well, what makes the flow happen, all right? Feeding, breathing, waste removal. But what's monitoring it? What's organizing it all? Well, it turns out that your immune system is monitoring all the mass that comes into you. If you get a viral infection, if you get a mosquito bite or a splinter, or the food that you eat, it all has to be monitored by your immune system. And in fact, your gut is loaded with immune cells. The bulk of your immune system is in your gut, which makes sense if you think about it. This is what's monitoring the mass that's entering you. And where's most of the mass entering you? It's the food you eat. So that all makes sense. And then if we look at the nervous system is monitoring information. So heat, sound, touch, smell, taste, odor, all of our senses are what's monitored by the nervous system. And we interpret that and then ultimately, ideally, are going to respond in a way that's going to promote our survival. So acquisition of energy and what to do with it in a particular environment are fundamental properties necessary for life. And once you get up to the level of vertebrates, both of those systems are very critically maintained by our endocannabinoids. All right. So, in particular, and it should be obvious to most of you who have any clue as to what's going on, that cannabis, when you consume it, is going to affect your nervous system. That's why you get high. But so many of the therapeutic benefits that come from, say, autoimmune diseases or cancer, et cetera, are largely coming from the immune system. All right, so here we have an example of an immune cell. It's called a neutrophil. And neutrophils are basically the foot soldiers of your immune system. They go out there and fight the first battle, and they die with a high frequency and have a short life. They live around 17 days. So here's the outline of the cell. And what you're looking at here is a specific collection of molecules that when you hit them with a defined wavelength of light, will absorb that light and then put it out as another color. So what you're seeing here, this red, is what's called fluorescence, the putting out of that color after the cell's been hit by some other light source, not of that color, okay? And what you're seeing here is that moves down the cell until it reaches the end of the cell. So here we have one cell and here we have another cell, okay? And you can see they're both lined up because the way this was generated was a chemical was placed on the end of a slide, and these cells migrate. That's how that's how you get inflammation when you have a splinter. You got cells that migrate out of your blood vessels and permeate through your tissues, and then use free radicals to nuke the problems, to radiate the problems. So what you're seeing here is how they do that. On the one hand, the directionality is because the cell is hearing through its receptors that it has to go to a place that has a higher concentration, basically, of signaling molecules. It's essentially if you were listening to somebody and you wanted to find them, you would follow the sound. Well, here you're following the concentration of these chemicals. And when it reaches the end, it turns out that this cell is in a solution here that fluoresces, not only because of the intrinsic fluorescence of this particular molecule, NADPH, but because that NADPH, the H part, it means it has extra electrons that want to react. And that's why we use that energy through a specific enzyme that will then formally spit out free radicals in the form of what's known as superoxide, which would then nuke the neighborhood, right? The problem with nuking the neighborhood is who's the neighborhood? We are. So constant chronic inflammation leads to mutagenesis, which leads to autoimmune diseases and cancer. This is just a similar kind of conceptually similar, showing that there's a flow, in this case, of the compounds involved in making the membranes of cells. So I want to, going back to this oscillatory control of things, even insulin production. Insulin is secreted in what they call a pulsatile fraction. It's because of oscillations again. Each high point is the release of insulin in one graphic representation. And now we can see that we have an involvement even in something like that. Cannabidiol targets mitochondria to regulate intracellular calcium levels. We spoke about mitochondria. That's where the metabolism occurs. That's where the free radicals are produced. What we didn't talk about was calcium. And calcium is a very critical messenger throughout our bodies. It's critical to nerve transmission, to immune responses, muscle contraction. Pretty much doing anything involves the release of calcium to stimulate either energy production or for the cell to die. So we have both ends of the story there. It can help you live or it can kill you. But here the critical thing is that cannabidiol regulates these intracellular calcium levels, and it's those intracellular calcium levels that regulate the oscillations that I just showed you. So going to cannabinoids and aging a little here, the etiology of all age-related illnesses has a free radical involvement. As we age, our weakest link breaks. So what we're going to look at is that what we're going to see is that a deficiency in cannabinoid activity promotes an early death, whereas the consumption of cannabinoids increases health and longevity. So free radicals are the friction of life, and your cannabinoids are the oil of life. Well, think about what friction means. You know, it's something wearing out. In this case, it's not just the change of chemicals, but it's the organization. That's the critical thing to understand, that the free radicals are not simply quenched, but rather there's a change in the pathways that generate them in an effort to minimize harm. And that's what your cannabinoids do. They create this massive shift in the flow and therefore the free radical production. So here's an interesting little thing. Hemp seed eating village in China holds the oldest, healthiest people. Why is that? What's the magic about hemp seeds? Well, first of all, you know, in China, in a small rural village, these are not going to be highly washed necessarily. So they will have little bits of the goodies that surround the seed pods, the bracts, which were originally, you know, the trichomes. So you're going to be taking in direct cannabinoids to some degree, but importantly is you're going to be taking in the essential fatty acids that are found in those seeds. Cannabis seeds are one of the healthiest things in the world. They have all the essential fatty acids, which we need. And in fact, we use those fatty acids to make our endocannabinoids. So when you have a doctor tell you, take fish oil, omega-3s are good for you, right away ask them, do you know what they're made into? And most of them will tell you no. They're made into your endocannabinoids. So all these doctors are basically trying to tell you to increase your cannabinoid level by eating fish oil. But then you go to the same doctor and you say, well, you know, the fish oil is not enough for my condition. I need to increase it a little bit more. What do you think about pot? Oh, we can't use marijuana, dangerous, addictive drug. So we're dealing with the ignorance of the professional establishment. And thankfully, you know, through the efforts of the people here at this conference and others, you know, the world is getting educated as to the scientific foundation of what's going on with cannabinoids. So what is aging? As an organism ages, the system moves closer to equilibrium. It's that simple. The ice is melting. You're running out of the capacity to maintain your organization. When death occurs, there's still energy in a lot of the molecules. You know, you can burn a dead person, right? And they'll give off energy, but the energy is no longer used to maintain our organization, but rather to maintain the organization of the organisms that live with us after initial death. Keep in mind that we have more bacterial cells, prokaryotes as they're called, on our body surface and in our tubes, so to speak, you know, your anus and your stomach and your mouth. Where was I going there? I got lost. In any event, so we're looking at what aging is, and we want to see how we maintain the system far from equilibrium. So what are the age-related illnesses? Circulatory illnesses, digestive illnesses, endocrine illnesses, immunological, musculoskeletal, nervous, reproductive, and the skin. So we're familiar with all of these from an aging perspective. You know, the number one cause of death is circulatory illness. Many people, unfortunately, have digestive illnesses, gut-related illnesses, be it irritable bowel syndrome or Crohn's disease or GERD. You know, there's so many opportunities in the passage of our food from the mouth to the butt where things go wrong, and they're going to go wrong with an increasing frequency with age. So we look at our endocrine system, again, that all has to coordinate everything. And as things start to fall apart, you know, we impact on that. In fact, your cannabinoids regulate your pituitary gland, which is known as the master gland. Well, if cannabinoids are regulating the master gland, what does that make them? You know, your musculoskeletal system, deteriorates with aging. And in all of these cases, you can see the contribution of free radicals to destroying the organization of the flow that is required to maintain distance from equilibrium and therefore health. So the nervous system, it's obvious, Alzheimer's disease is going to potentially bankrupt the industrial countries of the world. Well, guess what? Cannabis inhibits Alzheimer's disease, just the way it inhibits all the other diseases associated with this list that I have here. All right? Reproductive system. Your cannabinoids are very much related to that because they regulate sperm maturation, they regulate ovulation, they regulate fertility directly in the formation of the zygote, and further on, they regulate the development of the fetus. And when you look at skin, well, think about some of the things that occurs to the skin as you get older, It gets more wrinkled and full of discolorations, and ultimately, in many, many people, you wind up with skin cancer. And we'll see how cannabis could treat very dramatically and impressively skin cancer, as well as many other cancers. So the tree of life, the endocannabinoid system is uniquely suited to holistically modify the multidimensional interacting biochemical pathways that determine a system's health at any instant, as well as how it evolves over time. In other words, what you are today sets the tone for what you'll be tomorrow. And certainly eating properly and learning and educating and physical activity are all the things that we must do to maintain health. But on the other hand, they do that by maintaining free radicals, by producing free radicals. So those free radicals, again, are signaling the system to readjust. And what they're telling your body, if you're using your body, is to make more and healthier body. If you don't use it at all, then you're kind of encouraging its falling apart. Hence, exercise is good because it moves you further from equilibrium. Eating too much is bad, and we'll go into that a little later on. So this is a very dramatic example of the anti-aging properties of cannabis. So what we're looking at here is what's known as a survival curve. What percent of the animals that we're looking at are alive as a function of time? We're looking at mice here, so at time 0, they're all alive. And now we're looking at 3 different kinds of mice. CB1++ means that both parents of this mouse had functional CB1 receptors. The CB1 receptors are located all over your body, but in particular in your brain, and these are the ones responsible for you getting high. So in other words, if you can't get high because you don't have a CB1 receptor because both the mother and father lacked it, you die dramatically premature compared to those that have at least one copy, or both, from each parent of their cannabinoid receptor. Well, this right here is unambiguous proof of the requirement for getting high, so to speak, for maintaining endocannabinoid activity at whatever the basal level is for the species involved, mice or rats or humans. And then on the other side of that story, we're looking at this woman. She was 120 years old. And what is she doing? Smoking the doobie. Now, consistent with this is also science, because people say, well, this is anecdotal, doesn't mean anything. Well, the NIH, because they were always funded by NIDA, the National Institute of Drug Abuse, in order to show how bad cannabis was, kept doing experiments and not finding it being so bad. It was all the way back in 1972 that experiments were done that showed cannabis killing lung cancer cells from mice. And then it was promptly ignored for 30, 40 years. But they did experiments to show how bad it was. Couldn't follow up on the experiment that shows it could potentially cure cancer. But rather, we'll just continue until we find something bad, and we can focus on that because of the drug war. All right. So they did experiments where they fed mice very high doses of THC for 2 years. They would give them doses that were equivalent to the high doses used of Rick Simpson oil to treat cancer. And what did they find after 2 years? They never released the study until after it was leaked through an HIV activist group. What the study showed was that the mice lived longer and had fewer tumors. This lady would agree to that because she didn't die until she was 125 years old. And this is her family. They're all rather aged as well. So the fact that our government, or governments more appropriately, has outlawed an anti-aging drug that kills cancer is proof of their incompetence. This is the kind of thing we've got to drive home, that if you don't support cannabis, it's because you're ignorant and because you have fundamental problems with learning the data that's out there. And from a government who takes all of this money from its citizens to not be able to read the freely available science and come to the obvious conclusions is an example of how they are mentally ill. The governmental illness is what I call it. And we'll look into that further. So cannabis and cancer, well, what I'm showing you here is my database, okay? And if you look down here, you see I've got 12,764 articles in my database, all right? And we're looking at here, do cannabinoids have a therapeutic role in transplantation? The answer is yes. They, inhibit rejection. But the point here is just to show you that I have this database, and then we can look through different, the influence of cannabinoids on different things, Acute and chronic cannabinoid extract administration affects motor function in a Cree model of multiple sclerosis. In Colorado, they found that people who have MS drive better when they use cannabis. Not surprising. The muscles and nerves are working in coordination better. So we can see it's got an effect on autoimmune diseases, here we're looking at cardiovascular disease. So now I pulled out 194 references on cannabinoids and cardiovascular disease. For example, targeting cannabinoid receptor 2 in cardiovascular disorders, promises, and controversy. What we're going to ultimately see is that your CB1 receptor facilitates carbohydrate burning by the way it protects against free radical production. So it allows for more metabolism via carbohydrates in the electron transport system. And cells like that because it's a highly efficient way of making ATP. And what we'll see is that the CB2 receptor promotes fat burning, which turns out to be a unique way that cells protect themselves from free radicals. So as I mentioned, you have direct chemical interactions, but it's through the CB2 receptor in particular that you turn on the metabolic pathways that burn fat. And when they burn fat, they generate energy in a slightly different way that is not so dependent on the electron transport system and hence has a lower probability of producing damaging free radicals. All right, so that's very critical because when you look at heart disease, for example, it should be intuitively obvious from the concepts I'm presenting here. Think of heart disease where you have clogged arteries. Those clogged arteries are fat deposits. They're actually cells that have died that were loaded with fat. Well, cells that are loaded with fat are burning carbohydrates, making fat to protect themselves because they're not going to pass it through the electron transport system. And eventually that's what becomes the plaque. In contrast, if the cells are burning fats, then they don't accumulate fats. It's very simple. Once you understand the overall logic, and you see how you can apply this everywhere. So from the point of view of the nervous system, now we have, 830 articles on cannabis and the nervous system. And in fact, these are out of date. I'm up way beyond that now. This is from 2013. In any event, we know that the cannabinoid system obviously is very fundamental in the brain. We have receptors more than CB1 and CB2. I should mention that for completeness sake. It's just that these are the best studied. But there's the vanilloid receptors, which are your pain receptors that are involved with the endocannabinoid system. There's GP55. there's a number of pathways triggered by receptors that are involved in the endocannabinoid system, as well as receptor-independent means that also carry out the magic of the cannabinoid system. I won't go into the details here, but one example would be what they call retrograde transmission. Basically, your nervous system transmits from one nerve to the next to the next. And what happens here is the downstream nerve sends information back to the upstream nerve that it's getting too much activity and that's dangerous. So what it does is it makes endocannabinoids. It breaks down the membrane of the downstream neuron, what they would call the postsynaptic neuron. The membrane breaks down and is composed of essential fatty acids, and it winds up making anandamide and 2-arachidonyl glycerol, which are our endocannabinoids, which then go backwards across the gradient where they hit the CB1 receptor, which then changes calcium entry and protects the cell by not having it as active. So that's a very unique quality, retrograde transmission created during nerve transmission as a result of the endocannabinoid system. And it's that decrease in free radical production that makes cannabinoids beneficial for Alzheimer's, Parkinson's, Huntington's, etc. So in the skeletal system, it's the same thing with the role of cannabinoids in regulating bone remodeling. You see that, again, there's a balance between the activity of the CB1 receptor in terms of the type of bone that's produced and the rate of degradation versus the CB2 receptor. They have balancing influences once again. And the idea of balance, again, I want to emphasize that on the one hand, we're synthesizing ourselves and our components, and on the other hand, we're degrading them and spitting them out as waste. So we basically recycle ourselves constantly. And in terms of bone, what happens is if you have an imbalance where you're breaking it down faster than you're making it, well, that's what the aging is and the osteoporosis, et cetera. And in an effort to counteract that, what pharmaceutical companies did was they developed drugs that would inhibit the breakdown. But remember, life is dependent on flow. So if you inhibit the breakdown, you may be inhibiting the free radical producing aspect, but you're also inhibiting the flow, which is what keeps the system further from equilibrium and makes it healthy. All right. So what's the consequence with one of these anti-osteoporotic drugs that stop breakdown entirely of it inhibit what's known as osteoclasts. Those are the ones that break down the bone. What they found was they inhibited the breakdown. They had thicker bones, but women using it could literally just step off a sidewalk and get a fractured hip because the bones, while they were thicker, were much more brittle. Because basically, if you're inhibiting the flow, you're killing them. So you may be making more dead bone, but what you need is more live bone. So again, it's your cannabinoid system with its anti-aging properties that would be beneficial. And we look at cancer. There are hundreds and hundreds of articles on cannabis and cancer, and almost all of them show that cannabis inhibits survival of cancer cells. There are very few articles that show low-dose stimulation. And often that's what you see, different effects depending on dose with cannabis. That's what's called biphasic. But even here, where we're looking at cancer cells, we come across the roles of cannabinoids in bone remodeling, the role of lipid rafts, calveoli, and anti-cancer effects of endocannabinoids. We can go on and on and on because there are 900, actually it's close to 1,000 now, articles on this. So I'm going to give you some visually scary pictures now on squamous cell cancer. So here, a woman's arm, Australian woman. Australia has a tremendous rate of skin cancer. It's right there by the equator. And you had all of these fair-skinned limeys leaving the protection of the London fog to be irradiated at the equator. So they're all coming down with skin cancer. This woman and her two sisters and her mother and her father and her two brothers, they all have skin cancer. They, lived on a farm in Australia, a sugarcane farm. And after the cannabis was put on, the body expelled that tumor. It stayed there. It took a long time for this to all happen. Basal cells go away in anywhere from a few days to maybe 3 weeks when you put on just topical cannabis. Whereas with the squamous cell, it's a longer procedure. This one, start to finish, and we're not anywhere near the finish yet, obviously, was about 3 months. You can see that over time, you get more necrosis. That's all that black glop. The thing really stank and was extremely painful. And here, what we would do is we would put some saran wrap on it overnight because the extracts are such a sticky mess. They get over everything. You never get them off anything. So we'd put a little saran wrap on it. And in the morning, when she lifted the saran wrap off, the whole top of the tumor came off with the saran wrap. It was 30% decrease in tumor size for what was dying. And then as time continued, the healing process overtook things. And eventually, in the end here, it was fully healed and the patient had a clean biopsy. So we know that this can happen. This poor man here, you're looking at the top of his head. He had what doctors said was the worst case of squamous cell carcinoma they ever saw. And they wanted to cut off his scalp and cut off a piece of his skull and treat it and put it back. And he said, no, you're nuts. I'm not doing that. And the doctor said, well, you have to do something. So he went for a radiation treatment. Now, this is some of the criminal insanity that sadly exists in the medical population. You can't see the one up there, but there are 3 main tumors here. These tumors are drug resistant. Drug resistant tumors, when you treat them, typically grow better. This poor man had 135 irradiation treatments. You would have thought that they might have figured out somewhere along the line and it wasn't working. It took 130 times for them to figure that out. Duh. So he starts putting cannabis on, and you can start seeing how here, and another one back there are starting to respond, and you can see that black necrosis, and again, it stank like crazy. And, over time, it continued to eat away at those cancers. His doctor was so blown away because he said, nothing that we have will touch this cancer. They did the 130 irradiations and the chemo things as well. So the doctor couldn't believe what was happening. He said, put it all over his head because we don't really know where he has the cancer and where he doesn't. So what you're going to see now is the consequence of putting it all over his head, plus he started to take it internally. So there you see the poor man's head after we put cannabis everywhere. That's his skull. The cancer was eaten away right down to his skull. His head was opened like that for a year without having any infections because of the antibiotic properties of cannabis. He had to go to the hospital for another reason. And while he was in the hospital, he came down with the hospital infection. They put him on antibiotics to which he was allergic, and he died. So, back to what the doctors know or don't know. Ignorance is not bliss. They did a survey last summer, all right, of medical schools. And lo and behold, the results of the study are predictable. So no one should be surprised. Not one of the major medical schools surveyed had a department of endocannabinoid science or an endocannabinoid science director. None of them taught the endocannabinoid science as an organized course. And only 21 of the 157 schools surveyed had the endocannabinoid system mentioned. 13% mention it. Now, to show how absolutely insane this is, the major neurotransmitter system in your brain is your endocannabinoid system. Now, how can we have the major neurological transmitter ignored in our medical schools? This is totally incompetent ridiculousness. Conclusion: the purpose of the study was to point out the absurdity of ignoring a new science. We would hope this study causes medical schools to rethink their position and welcome this new science. We call on deans of all medical schools to start organized courses in cannabinoid receptor science, its modulating effects on homeostasis. If the medical schools in your state do not teach endocannabinoid science, you should discuss ways to incorporate the study of endocannabinoid science into their curriculum. So here's an example that on occasion, even doctors can change their minds. Sanjay Gupta had his filming crew originally contacted me and filmed me for 3 days. I provided him with lots of the science that I'm discussing you with, but they never put my movie on. Instead, and wisely, they put on the picture of Charlotte, Fiji, the girl who has Dravet syndrome. Dravet syndrome, is a genetic condition that gives people just horrendous levels of seizures. A lot of these people have literally 200 seizures a day because they're seizing all the time. They don't undergo normal development, and typically none of the available drugs can prevent the seizures. Sometimes they'll reduce it. I was with a girl the other day who went from a couple hundred down to 20 or so a day and wants to get on cannabis. But the doctors are concerned because they don't know the effects of cannabis. Duh. The kid has hundreds of seizures a day, and you're worried about putting them on a non-toxic cannabis extract? Keep in mind, cannabis has no known lethal dose. So compare that to, let's say, aspirin. There's a measure known as therapeutic index. How much of a compound of a drug do you need to take to have the effect that you're looking for, therapeutic effect, pain relief, let's say headache goes away with aspirin, versus how much will kill you? Well, aspirin has a therapeutic index of 15 to 1. You take 2 aspirins, you get rid of your headache. You take 30, you bleed to death and die, potentially. In contrast, if you look at chemotherapeutic agents, sometimes they're 2 to 1. You got to be very, very careful or you kill the person. In fact, that's what happened to my father. He was killed by chemo and radiation. Now let's look at cannabis. What's the therapeutic index of cannabis? They estimate it to be 40,000 to 1. If you want to die from cannabis, have somebody drop, a big bale off the roof and hit you in the head. Otherwise, you're not going to die from it. So what Sanjay Gupta said, long before I began this project, I had steadily reviewed the scientific literature on medical cannabis from the United States and thought it was fairly unimpressive. Well, he didn't read enough of it, but we'll let him slide with that because he wound up doing the right thing in the end. Reading these papers 5 years ago, I was hard to make a case for medical marijuana. Well, that's basically BS, but we'll let him slide again. I even wrote a paper on the Time magazine article back in 2009, why I would vote no on pot. Well, here I am to apologize. I apologize because I didn't look hard enough until now. I didn't look far enough. I didn't read papers from smaller labs in other countries doing some remarkable research, and I was too dismissive of loud chorus of legitimate patients whose symptoms improved with cannabis. Why should we listen to the people? I continuously meet doctors, and no matter what you tell them, the only thing they can say back is, we need peer-reviewed double-blind studies. We need peer-reviewed double-blind studies. Well, my question is, how many people need to anecdotally tell you that I've cured my cancer, or I got rid of my epilepsy, or my pain is gone and I'm no longer taking narcotics, or I used to be an alcoholic? How many of those people do you need to see before you're going to believe it? I believe it. I'm a very conservative scientist. But I don't care whether there's a peer-reviewed study or not. When you watch somebody's Kaposi sarcoma fall off, when you watch their skin cancer fall off, it's dramatic. But I want to emphasize, and it's the sad truth, it does not work all the time. There are many cases. I just lost my husband-in-law. My second ex-wife's husband just died a week ago from lung cancer that metastasized everywhere. And he was on high doses of high-quality oil for over 6 months. And it certainly did help him, exit a little bit more gracefully. There's no question about that. But it did not prevent or reduce his cancer. So what we want to do is understand what is treatable by cannabis and what is not, why it works and why it fails, because then we can do the kind of tweaking that might be more successful. And where I'm going with this is, while I certainly would not take chemo at this point, I believe that there are going to be circumstances where chemo and or other drugs, when used often, I think, in small quantities, will help shift the balance in a way that will make cannabis more lethal for some of the cancers that it currently is not working on. When I say cancers, I don't mean breast or brain or whatever. I mean within each category, because ultimately there really only are two kinds of cancers. There's drug-sensitive cancers and there's drug-resistant cancers. Drug-sensitive ones you kill with various agents. Drug-resistant ones kill you. Well, it turns out there's more to that story, and it ties in with the very nature of what we're talking about here, metabolism, the flow of energy. It turns out that all drug-sensitive cells are burning carbohydrates, and when you treat them, they undergo what's called apoptosis, which is a cell death caused by too many free radicals. So what that should tell some people is that under certain circumstances, the use of antioxidants while you're taking chemo is probably not very smart. In contrast, well, and also let me mention that the concentration of chemotherapeutic drugs used to treat a person is typically 100 times less than what you need to kill that same kind of cancer in a tissue culture. And what accounts for the difference is the tissue culture does not have an immune system. And when you damage cells, they send out signals, again, back to the voice and hearing, they send out chemicals that tell other cells, that they're in trouble, basically. And they get monitored by the immune system, which is either going to help them to get better or going to kill them. We're happy whenever cancer cells die. So this is Charlotte, who was using the CBD. Is the endocannabinoid system responsible for evolution? I got a little screwed up here, didn't I? I was working on this earlier. I obviously didn't fix it. Let's see if I can dissect that. Is the endocannabinoid system an evolutionary tool to create and then rebalance excess flow? Yes. Is the endocannabinoid system responsible for evolution of human intelligence? I would say yes, and that's something I'd like to go into right now. So, prior to the evolution of vertebrates, you did not have an endocannabinoid system. And what Charles Darwin said is that survival of the fittest does not mean survival of the strongest, and it does not mean survival of the smartest. It means survival of the most adaptable. So that's exactly what cannabinoids do. That's what we're looking at, how they provide for adaptation. Now, the chemicals, what's known as ligands that bind to the cannabinoid receptors, they've been around ever since protozoa. First single cell, true nuclei cell, eukaryotic cell. And multicellular organisms were formed that had no cannabis receptor, the insects and the crustacean. They have very organized structures. If you look at insect societies, everything's pre-programmed. They cannot make iPods. What happened with the evolution of the vertebrates was a new level of flexibility, of adaptability that occurred. Well, guess what? That's when the cannabinoid receptors first appeared, and they regulate everything, and they regulate our ability to embrace change on all levels. So, yes, the endocannabinoid system has a very critical role in the evolution of human intelligence because it makes us flexible mentally. That's what we need to be able to do, to adapt. Think about it. A lobster with its exoskeleton can't adapt to the same degree as we can where our skeleton stretches, right? Or your skin stretches. The exoskeleton of the insect can't, but your skin can. And internally, your muscles can grow and your bones grow and thicken. If you look at a skeleton of a slave, you can see where the Muscles were attached and they needed to be reinforced by extra growth, etc. You can't do that if you're an insect. So this whole idea of adaptability is carried through. Think of our brains. What's the big characteristic, really, of how cannabinoids impact on the brains of vertebrates? Let's look at humans. It's a very critical factor here. Open-mindedness, what does that mean? It means that you could replace bad information with new information and embrace the new information. Your cannabinoid system is responsible for that. I got nothing to drink, so I'm trapped up here. So pardon the coughing. In any event, your cannabinoid system is responsible for that neurological plasticity. The CB1 receptor is known to promote both neurogenesis, the generation of new nerve cells, as well as plasticity, the making of new connections. So these are all the things that happen as we learn. And certain of the chemicals involved in learning are too excitatory. Remember, too much calcium release and free radical production? They're called excitotoxins. And cannabis helps protect against that. That's tied in with the whole Alzheimer's story. So we have these very, very fundamental links with cannabis and the evolution of our intelligence and our open-mindedness, which is a representation of man's intelligence. So let's look at those knockout mouse, the mice that I showed you earlier, where they either had or didn't have the cannabinoid receptor. Well, the mice that don't have a cannabinoid receptor are stuck not being able to learn new things. You put them in a tank with cloudy water so they can't see what's there. You take normal mice or you take those knockout mice that can't get high, and you put them in that cloudy water and you have a platform in it. And they swim around kind of freaking out because they don't like swimming. They find the platform, and then if you take them out of the water and put them back in, they'll go right to the platform. Now, if you change the position of that platform and you take the mice and you put them in, they'll swim around again until they find the platform. And both the normal mice and the knockouts that can't get high find it. But now if you take them out and put them back in, the wild-type mice, the normal mice that can get high, go to the new place, whereas the old place is where the cannabis-deficient mice go. They couldn't relearn. They were stuck with old information, all right? This is the drug warriors. They can't learn. Some of them can't. Some of them can, but are just uneducated. Some of them are like those knockout mice. They're broken. But in any event, you have two kinds of people. You have people with above average levels of endocannabinoids regulating open-mindedness. And you have the other half of the population is below average. And are there consequences to that? I would say, yes, there are very significant consequences to that, because the people who cannot embrace newness are cannabinoid deficient. And they're the people, I believe, who run the world. Because what they're trying to do is to overcome their natural inability to not adapt to change. And the way they do that is by trying to keep everything the same. They don't want change because they're too stressed by change, because they're too unhigh. And these are the people who tend to be aggressive and angry and want everything just the way it's supposed to be because they know what's right. And they're so certain of what's right that they're willing to put you in jail because you think differently and use cannabis. This takes us back to what I alluded to earlier, the whole idea of racism. The people who use cannabis are the people who are more cannabinoid endowed. The people who don't use cannabis are as a general rule, are the people who are less cannabinoid endowed. Well, skin color, we protect against racism based on skin color, which is just a couple of gene changes. You can have a black person who's more white than he is black, because it's the rest of everything. Skin color is so minor. Well, here we have our endocannabinoid system that regulates everything, and you're going to have people who have a more robust system and people who have a decreased system. And if the more robust cannabinoid system are the ones who explore and try to do things new, like smoking marijuana and then using it because of what they learned, we are discriminated against by the cannabinoid deficient people. I call them blips, backward looking people, because they can't look forward unless the future is the same as the past, because otherwise they'll be stressed by their inability to embrace change because of their deficiency of cannabinoids. You know, on the other side of that, one of the characteristics of people who use cannabis is that they are optimistic. What does optimism mean? It means you don't know what the future holds, but you're willing to gamble and embrace it. You're a risk taker because you're optimistic, because you're high enough to embrace change. And, you know, along those lines, the cannabinoid receptors in your brain have a certain degree of what's called constitutive activity. They're always turned on, even when they're not getting stimulated by THC or the endocannabinoids, anandamide, and arachidonic glycerol, and others that exist as well. So this is what we've been talking about here, flips and blips. I do believe that the governments of the world are run by backward-looking people because they're trying to control everyone else so that they can control the future, that they're afraid of embracing change. But there's a real important consideration here. Man has had a tremendous impact on our environment. And if our policies continue to be made by the whores that run the government and are incapable of taking in new knowledge like man's impact on the environment, we as a species will go extinct like most species have in the past. So from an evolutionary point of view, we see a continued increase in nature's selection for cannabis activity. Well, can't we embrace that? When we use cannabis, all we're doing is tasting the future of humanity. Because if the cannabinoid system has continued to increase its activity from its first emergence with vertebrates to the point where it's the major neurotransmitter system in the human brain, that tells you that, well, this is the will of God, so to speak. Whatever God you believe in, you know, for me, it's generalized open system dynamics, it's physics. But regardless of what you believe in, this is the way things work. So wisen up, if you can, and embrace it. And that means for those of us who are open-minded enough to embrace this intelligence, we have a fundamental right and need to use cannabis in order to make ourselves healthy, wealthy, and wise. And this is what we just talked about. We just talked about that. Going over all of these things. So now let's look at, again, how dramatic this story really is. It turns out that mammals, organisms with mammary glands, okay, produce milk, nurture their young much better than anyone else, you know, previously from the species evolution point of view. And these mammals, guess what? They've got psychoactive endocannabinoids in them. And think about it. You know, the kid's head was all squished. If we're dealing with humans going through that birth canal, you know, there's a lower level of oxygen. Oxygen is very toxic. It's like a free radical. If you give newborn preemies pure oxygen because they have undeveloped respiratory systems, and that was tried a number of years ago, they went blind because of the toxicity of the too high oxygen. So here we have cannabinoids in mother's milk. It protects the infant that just came out, is breathing oxygen now instead of getting it through the placenta. The infant needs to start suckling. It needs to feel comfortable and mellow. If you've had a kid and you've seen how they respond to nursing, what do? They get quiet. They typically go to sleep. It's how you make them happy. Well, should we arrest all nursing mothers for getting their little infant stoned? Or maybe we should just arrest all nursing mothers, or rather all women, period, for walking around with paraphernalia. And here we show that if you inhibit the C1 receptor in the newborn mice, you know, they have social emotional behavior. Well, one of the things that I think is worth exploring and suggesting is that a lot of our our back-looking politicians, perhaps they were not breastfed. and are suffering from post-birth traumatic stress disorder. So here we have some examples of a backward-looking person. And we have an example of a forward-looking person. And think about it in history. You know, if everything was random, we'd expect to see, you know, half the leaders of the world in history being, you know, forward-looking, peace-loving, et cetera. Instead, look back at the history of humanity. You know, we've got Genghis Khan and conqueror after conqueror and Hitler and Stalin and, you know, Cheney. Whereas we've had who on the other side? Mandela and Gandhi, you know, a very much more limited repertoire, which is what I say confirms the thought that we have cannabis deficient people running the world, historically and presently. And here it shows, these are peer-reviewed papers that show various traits that I would associate with being CB1, you know, having sufficient or not cannabinoid activity. So although political views have been thought to arise largely from individuals' experiences, research suggests they may have a biological basis. Of course, everything's going to have a biological basis. There's no separation between the mind and the body. They're all one. They're all part of the whole. In a group of 46 adult participants with strong political beliefs, individuals with measurably lower physical sensitivity to sudden noises and threatening visual images were more likely to support foreign aid, liberal immigration policies, pacifism, gun control, whereas individuals displaying measurably higher physiological reactions to those same stimuli were more likely to favor defense spending, capital punishment, patriotism, and the Iraq War. Well, doesn't that sound like what we just talked about with blips and flips? And, oops, this is another one that somehow did not work correctly. But it says the same kind of a thing, basically, that we have a biological basis for being either open-minded or not. So, you know, what kind of a world do we want to have as our future? And which kind of world is going to sustain us? And therefore, we need to continue the evolutionary process. And that's what we've seen happening now across the globe as people vote and demand the right to use cannabis. I just put this in here to make everybody happy and excited. This is what used to be, at least, I don't know anymore, the largest indoor grow in Colorado. It was 40,000 square feet and produced about 500, the maximum that I'm over 500 pounds of bud a month. So current marijuana laws are inhuman. They need to be changed. They're based on ignorance and fear. In reality, cannabis prohibition is a fundamental violation of human rights. It's racism, the blips versus the flips. We're dealing with genocidal racism as a result of one genetic group, blips, incarcerating and reducing the probability of reproductive success of the other groups. You know, you don't have kids as easily when you're in jail, and you certainly bring them up properly. So this is the solution. Give peace a chance. We've done a ridiculous experiment of prohibition for all these years. Now it's time to do the opposite. I would suggest we have a negative tax on cannabis. The government should be feeding us cannabis because it's the solution to the healthcare crisis from an economic point of view, and from a human point of view, it relieves countless quantities of suffering for so many different diseases that we've got to get rid of the idiots that are running the world. And I'll leave it at that.